topic 2-4, part 1. This section deals with equations that either contain one solution, no solutions, or infinitely many solutions. The first one we're going to talk about is an equation that contains one solution. A linear equation in one variable has one solution if and only one value of the variable makes the equation true. Let's look at this example. 57.9 minus 98.2y equals to 303.4. To solve this equation, we want to isolate the variable, just as we've been doing previously. So let's subtract 57.9 from both sides. Subtracting 57.9 from both sides. As you notice, the 57.9's cancel. We end up with negative 98.2y equals 2. When you subtract 303.4 minus 57.9, you get 245.5. To finish this problem, we need to divide both sides by 98.2. Dividing both sides by negative 98.2. Negative 98.2 divided by negative 98.2 cancels. We end up with y equals 2. When I divide on the right-hand side, I get negative 2.5. Therefore, this equation has one solution. This equation has one solution, and the only solution is negative 2.5. Next, let's look at another type of problem. This example has no solution. So let's look at it. A linear equation in one variable has no solution if no value of the variable makes the two sides of the equation equal. So this is an example of an equation that has no solution. So let's begin this problem. I see that I have a number out in front of a parentheses, which tells me to begin with distributing. So I'm going to distribute 3 times 2g gives me 6g plus 3 times 4 gives you 12 equals to 6g plus 9. I cannot solve, or I cannot combine on each side of the equal sign. Therefore, I do have two g's, one on one side and one on the other. So let's move the 6g from the right by subtracting 6g from both sides. If you subtract 6g from the right-hand side, the g's cancel. And if you subtract 6g from the left-hand side, the 6g's cancel. This is the first time that we've ever had a problem where the variables canceled on both sides. When the variables cancel on both sides, bring down the two numbers that are left. Notice that these two numbers do not equal. Since these two numbers do not equal, your answer is no solution, because this is a false statement. So this is the type of equation where the answer would be no solution. When the variables cancel and the two numbers do not equal, it is a false statement, and your answer is no solution. And let's look at one more example. This is an example of an equation where you can have infinitely many solutions. A linear equation in one variable has infinitely many solutions if any value of the variables makes the two sides of the equation equal. Two sides of the equation equal. So looking at this example, I have 9 plus 4p minus 2 equals 2p plus 3p plus 7. All right. I cannot distribute in this problem, but I can combine. I notice I have two constants on the left side, so my first step in this problem is I'm going to combine. 9 minus 2 gives you 7 plus 4p equals 2. On the right side, I see that I have two p's. That's 1p plus 3p is 4p plus 7. Now I see that I have variables on both sides. I'm going to move the one from the right by subtracting 4p from both sides. If you subtract 4p from both sides, the 4p's cancel on the right and the 4p's also cancel on the left. So now bringing down what I have on each side, I have a 7 equals to 7. This is a true statement. Therefore, when the variables cancel and the two numbers do equal, the equation has infinitely many solutions. So your answer to this problem would be infinitely many solutions.